We're talking about pre-calculus, the Edgenuity section 8.2, which is equations of ellipses. The plural of an ellipse is ellipses. We have two objectives, two pretty big objectives. One is to identify the center, foci, directrix, and vertices of an ellipse from an equation or graph. The second is to write the equation of an ellipse from a given graph or information about its center, foci, directrix, or vertices. So let's look at one of these problems here, and we'll see what we can do. So here you'll see the question is, what are the unknown values in the equation of the ellipse? And this equation is a simpler, sort of the simplest version of the equation of an ellipse. It is one that presumes that the center is at the origin right there. So we got to know some things like, what does this a squared mean? What does the a mean? What does the b mean? The x and y represent variables that will vary as we draw it, so we don't want to fill in x and y, but we do want to fill in a and b. So a is the longer distance from the center to a vertex. And so from here at the center out to either this point or this point, that distance will be A. Okay? B is the shorter distance. Of the same idea. From the center to what's called a co-vertex. That is the shorter vertex from the center still. So that's what A and B are. They're just distances, and those distances are from the center to a vertex or co-vertex. They call it the co-vertex or the minor vertex. We have a major axis, which is the one that is the longer axis, and then we have a minor axis, which is the shorter axis. Okay? So, from the center here, actually, let me change colors so that we can see the rest of this work a little bit easier. So from the center here, which is at 0, 0, out to a vertex, that'll be the distance A, okay? And that distance A, which we're talking about right there, is going to be 4, as you can see. It's pretty easy to see in this one. So A equals 4. And then the distance B is from the center to either one of what we call these co-vertices right there, and that will be our distance B. So A is the longer one. Now, they can be like this. Ellipses can be like that, and in that case, this is the A distance, this is the B distance, just so you're aware. Okay, so ellipses can be either one. And I think you can tell that the B distance there is a distance of 2. So if you wanted to write the equation, fill in everything, you'd say x squared over a squared, which is 4 squared, which is 16, plus y squared over b squared. B is 2, so 2 squared is 4, equals 1. So that's a pretty simple problem and example. I will pause to allow for questions here. There being no questions, we will move on. All right, so let me read this question to you. It's a fairly long question. It says, an ellipse has vertices at 5, 0 and negative 5, 0, and co-vertices at 0, 2 and 0, negative 2. On which line will the foci be graphed? That's the first question we're going to ask. Where are the foci located? What types of lines will the directrices be? There should be an R there. And where are the directrices located? And I've isolated this little formula here that the distance for a directrix is calculated by doing a squared over c. So the first thing I'm going to do is graph this and talk a little bit about what all these terms mean. You'll learn these terms as you go through 8.1 and 8.2, but let me graph and talk about them as we go, okay? So here's our graph, and it says we have vertices at 5, 0, so 1, 2, 3, 4, 5, 0 right there, and negative 5, 0, 1, 2, 3, 4, negative 5, 0 is right there. And then co-vertices or minor vertices at 0, 2 and 0, negative 2. So the ellipse looks a little bit like that. I'm just sketching here. So that's what the ellipse looks like. You can tell, and then you can double check that the center is at 0, 0. You can tell that because of where the vertices happen on both ends. Halfway on the x values here, halfway between those is 0. Halfway between these two is 0 in the y direction. So that gets us a center at 0, 0 at this point. Then there's this term, foci. Foci is the plural of the term focus. So we want to know where the focus points are. That's another way of saying it. And the foci are along the major axis, that is, along the longer part, traveling from vertex to vertex through the center, and they're always inside somewhere. Now, I don't know that this is the exact spot for them, but I know they're somewhere in there. And let me change colors for a moment to illustrate something. Okay? This distance here is what we call the A distance. Okay? And we already talked about that. This distance is called the B distance. Now, this distance here, from the center out to a focus point, is called the C distance. And here's a relationship between them. Okay? If you do the C distance right there, and the B distance right there, and you create a hypotenuse for a right triangle out of that, that distance is also A. That is one of the fundamental definitions of what it means to be an ellipse. That relationship has to hold. You have to be able to build a right triangle in that way. Okay? So then, as you should be able to tell from that, that gives us a calculation, which is that B squared plus C squared equals A squared. Okay? And that is a definition that's going to hold for all ellipses. And there are going to be varied definitions for some of the other conic sections that hold true like that too. Now, I don't know why they don't give it to you like that in Edgenuity. They just go right to the manipulation of it, which is that A squared minus B squared equals C squared, which I think is because they're trying to keep A, B, and C sort of in order. But if you have the picture, if you have this picture right there, then you can simply figure it out each time based on Pythagorean theorem, which is something that you already knew. So this is the way I always remembered that. Okay? So that is, again, my dog. So I can use knowledge that I have to get knowledge that I don't have based on this, right? If you just look at my picture or even look at things up here, I know the B distance. The B distance is 2, so it's 2 squared plus C squared equals A squared, and I know the A distance either from looking at that or from looking at the picture. The A distance has to be 5. So I have that relationship, right? So 2 squared is 4 plus C squared equals 5 squared is 25, and then I can subtract 4, and get that C squared equals 21, and so C is the square root of 21. And you might want to put that into a calculator and get an approximation for it, and I think if you do that, you get approximately 4.58. So, okay. So that's the distance C, and what that tells us is, okay, first of all, we know that the foci are going to be on the line, which is this line right here. They're going to be on the line y equals 0. So they're going to be on the line y equals 0. So that's one thing that we can tell. Where are they located? Well, they are this distance, actually only approximately that distance, so really that distance, away from the center. So if you think of it this way, the center is at the point 0, 0, and never moves up or down. So this 0 is going to stay static, right? So focus point 1, which maybe we call that one, the positive one, and then we can call the negative one focus point 2. We could have labeled it other ways. That doesn't really matter. So focus point 1, we're going to add this value to the x value. That is, we're going to move in the x direction a positive amount that much. So focus point 1 will be at square root of 21 and 0. Focus point 2, we will move in the negative direction by this much. So it will be at negative square root of 21 and 0. Now, if we had some other center, we would go through the same process, except for you would be adding and subtracting that value from whatever it was there, unless you were moving in the y direction, and then you'd do it there. Okay? So going back and forth between the picture and what you're calculating can be extremely helpful here. It can really help show you how things are moving, which direction they're moving, and help tell you, okay, I need to add things, subtract things, all that stuff. So now we have focus points. We know where they're located, so we've done both of those things. So where are the foci located? They're at square root of 21 and 0 and negative square root of 21 and 0. And I think Edgenuity actually asks you to put in the decimal approximation instead, but that's actually more accurate. Okay? What types of lines will the directrices, there should be an R there and an R there, sorry about that. What types of lines will the directrices be, and where are they located? That is, what is their equation? So then we got to talk about what the directrices are. So I'm going to erase a bunch of this and redraw the picture with so that it's a little bit cleaner, so that we can figure this out. So I'm going to erase all the stuff that I wrote, and I'll redraw the picture so that it's clean again. So we were at negative 5, 0, 5, 0. We were at 0, 2, and 0, negative 2. So it kind of looked like that. Then we had foci in here somewhere. And now we want to talk about these directrix things. And the directrix are these vertical lines or horizontal lines, depending on how whether the ellipse is tall or wide. This one happens to be wide, so these are the directrix lines. This is a directrix line, and there's another one right there. And the distance from the center to the directrix is the distance d, which you calculate this way. So we actually have all that information, right? We know that A equals 5. We know that C is approximately 4.58. What type of lines will these be? Well, in this case, they're vertical lines. So that helps us. So squeeze that in here. They are vertical lines. And where are they located? Well, they're located a distance d from the center. So we have to do that distance d, which is a squared over c, which is 5 squared, 25, over approximately 4.58. This is actually an approximate now, which comes out to approximately, this is something that you can do on a calculator, and I believe it comes out to approximately 5.42, if I'm remembering correctly. Let me redo it on a calculator just to be sure. .46. So this comes out to approximately 5.46. And so that distance will hold in the negative side also. So we could say directrix 1. We could call this directrix 1, directrix 2. Directrix 1 will be at x equals 5.46, because that's the distance from an x value of 0 out to the directrix is a distance of 5.46, so it'll be at x equals 5.46 since we're starting at 0. And that second directrix will be that same distance but in the negative direction. And again, drawing the picture helps here, right? I cannot emphasize enough how if you draw yourself the picture of this stuff rather than just trying to hope that you can manipulate it in your mind, helps so absurdly much in this, okay? I'll pause and ask and allow some questions here. Okay, there being no questions, let's move on. Let's find h, k, a, and b for the ellipse and write the equation of this ellipse. All right, so as you see from the picture, or as you should see from the picture, we have moved on from having the center at 0, 0. Now the center is here somewhere. We don't know exactly where. But we can figure it out. And in cases like this, the center is what we call the point HK. This is typical for every conic section. Ellipses, circles, parabolas, hyperbolas, all the different conic sections have this same notation. The center is at HK. Okay, and then A and B are still, A is this distance here, B is that distance there. So we need to have these three things because the equation for the ellipse looks like, well, in this case, it looks like x minus h squared, it's always x minus h, over a squared. A is always the long one in an ellipse. So if it had been, this one's wider than it is tall, so because of that, the a value is going to go under the x because the a travels in the x direction. But if it had been taller than it is wide, then the a would have gone under the y stuff because it travels in the y direction. So x minus h all squared over a squared plus y minus k all squared, which the y and k always stay paired, over b squared. And again, it's b because the y direction happens to be the shorter of the two directions. And the equation of an ellipse always equals 1. So there's a lot that we can fill in here just by looking, okay? If you look here, because A only travels in the x direction, then the y is going to stay static there. So one thing I know about the center is that the y has to be 2, because I'm going to travel from that major vertex to the center, and I'm only moving in the x direction, so the y has to be that value of 2. Similarly, when I travel along the minor vertex here, I'm only traveling in the y direction, so the x has to stay static. So the center has to be at 3, 2. The x value has to be 3. So I have the center. I can actually count to figure out A, or I can calculate it. I can say, okay, from -2 to 8 would be a distance of 10, right? From 0 to 8 is 8. From 0 to -2 is 2. So 2 and 8 together makes 10. And that's all the way across. So halfway across, that is to the center, has to be 5, right? So A has to equal 5. And we could have counted that too, right? And B, same idea. So from the center here, if I calculated all the way down also, then it would go from 6 to -2. From 0 to 6 is 6. From 0 to -2 is 2. 6 and 2 is 8. Half of that is 4. So the B distance has to be 4. And so now I have everything that I need to fill in for the equation. X minus h. H is 3 squared. Over A squared. A is 5, so A squared is 25. Plus y minus k. K is 2. All that squared. Over B squared. B is 4, so 4 squared is 16, and the whole thing equals 1. And there's the equation of the ellipse. I'll pause here for a moment to allow for questions. There being no questions, I'll move on. So another piece of information with different information about an ellipse. So in this one, we have a center at 3, 1, a focus point at 8, 1, and a directrix of x equals 36.8. So we want to know what the equation of the ellipse is. So again, I like to draw these and be able to look at them before anything else. So let's make a drawing here. I got a center at 3, 1. Let's say that's 3, 1 right there. A focus at 8, 1. So 3, 4, 5, 6, 7, 8, 1 is a focus point. So that's my C distance. So my C distance is 5. because I had to move from 3 to 8. 8 minus 3 is 5. So I know my C distance. What I don't know is my A distance, but I do have that the directrix distance is A squared over C. So I have to figure out the directrix distance from where the directrix is placed and then where the center is. So remember, this right here is the center. This is a focus point. Let's call it F1. And then way out here at 36.8 is the directrix. And somewhere in between there is the actual vertex on that side. Okay? So I don't know what A is, so I don't know where that vertex is, but I can figure it out. Okay? So remember, I've got 3 here, so what I really want to know is what's the distance from there to there. That distance is D. And it's pretty simple. If it's at an x value of 36.8 and I start at an x value of 3, I just do 36.8 minus 3, so 33.8. And that'll get me what I need. So if my D is 33.8 and it equals A squared over C, and my C is 5, then I just multiply by 5 on both sides and do a calculation. I'll just use my calculator again to do 33.8 times 5, and that gives me 169, which is pretty convenient, equals A squared. And actually what I need is A squared, right? Because I'm going to do x minus h all squared over A squared plus y minus k all squared minus b squared equals 1. I'm trying to write the equation so I don't even have to know what A is, but A is the square root of that, and if you know your squares for a while, you know that A is actually 13. But we don't need A. We need A squared. So this is enough, right? So I know, okay, A squared equals 169. I'm going to put that there because I need to erase these calculations to continue my drawing. Okay, so now somewhere down here is my distance B, and somewhere over here is a vertex, and let's say it's there. I don't know that it's there, but what I do know is that from the center out to a minor vertex, and from the center to a focus point creates a right triangle where the hypotenuse of that right triangle is the distance A, right? So this distance is what we call C, this distance is what we call B. That might make it a little bit clearer. This might too. I don't know. That's the center, right? Okay. So now I can use the fact that I know A squared and I can calculate C squared to do this right triangle, right? Because B squared plus C squared has to equal A squared in this right triangle. I don't know B squared, But I do know c squared, that's 5 squared is 25. I know a squared is 169, so I can subtract 25 on both sides and get b squared, which is all I need. That's all that's left, right? Because I already have h and k right there. I was told the center. Now sometimes you might have to calculate the center, and if I do 169 minus 25, you'll find that that comes out to 144. So b squared equals 144, and the puppy approves, or disapproves, I can't really tell. And then we can put all of this into our equation. So x minus h is 3 squared, over a squared, because the ellipse is going to go like that and come back around, something like that. Again, that's a super rough sketch, but over a squared, because it's wide instead of tall, which is 169, plus y minus k, which is 1, all squared, over b squared, which is 144, equals 1. So here is the equation of the ellipse. I'll pause for a second, let you look at that, give you a chance to ask questions. Okay, there being no questions, I'll move on. All right, what are the vertices for the ellipse with this equation? So now we're giving you an equation, and we want to know some stuff, right? So, some things that you can tell. Since the bigger number is underneath the x, this is wide rather than tall. Okay? So that's one thing I can tell. The bigger number is under the x, so this is wide rather than being tall. That is, the longer axis, what we call the major axis, travels in the x direction. So that's one thing I can tell. This is then a squared, so from the center out to a must be the square root of this number, so that distance must be 4, so a must be 4. This distance is the distance along the minor axis to one of what they call the co-vertices, and that number squared, so the square root of that, that's the b distance, and that is 2. So we know that. The vertices are there, and that's both a distance of 4. So now if we knew the center, we could figure out the rest of it, right? So where is the center? Well, the center is at HK, and there's H, there's K. So, let's be a little more careful here. So it's x minus h, so h is 6, and it's y minus k. So the fact that it's plus 7 here means that we need to be the opposite. That is, we're the opposite of negative 6. We have to be the opposite of plus 7. So that is negative 7. So our center is at 6, negative 7. Okay? So our vertices are going to move from there. Vertex 1, let's label this. Vertex 1, vertex 2. I tend to move in the positive direction first, the negative direction second. But you could label them however you want, really, as long as you know. So the idea is that I started at 6, 7, and I moved in the x direction a distance of 4. So at 6, -7, sorry. So what I didn't move at all was in the y direction. So in the y direction, the vertex stays at -7, right? So if I move from 6, if I move 4 in the positive direction from 6 in the x direction, I go from 6 to 6 plus 4 is 10, right? Because this center is at 6, and then I move a distance of 4 in the positive x direction, which means I add 4. And then my vertex 2, also the y direction does not change, but the x direction moves 4 in the negative direction, that is backwards. So if I go 6 and then move back 4, I get to 2, that is 6 plus -4, right? So there are my vertices. Now, you could do your co-vertices also, or your minor vertices, CV1 and CV2, and you could do the exact same thing, right? CV1, this time the x isn't going to move, and I'm going to move +2 in the y direction, so I'm going to go from -7, +2, that is up 2, so that's going to go to -5, and co-vertex 2, also the x isn't going to change, and then I'm going to go -7 and down 2, that is 2 in the negative direction, which will give me -9. So now I've been able to talk about all of the vertices. I'll pause here, allow for questions. There being no questions, I'll move on. Write the equation for the graph. All right, pretty simple. We need h, k, a, and b here. So let's start with the center. We should be able to figure this out. This point here is -2, -1. That point there is -4, -1. This point here is -3, -4, and this point up here is -3 and 2. So as I look, the center, if I look at these two, the center has to be at an x value of -3. And then as I look at these two, that is these 2 points here, the center has to be at a y value of -1. So there's my center. Easy, right? That's my h and my k. Now I need my A and my B, which is similarly easy, especially now that I know how far I'm going. My B, which is always my short distance, is just a distance of 1, right? I go from -3 over to -2, or from -3 over to -4, that's a distance of 1. My A distance is this distance right there, and that distance I'm going to go from -1 up to 2, or from -1 down to -4, and either way that distance is 3. So I could have especially given a really accurate version of this drawing, I could just count these, presuming that the marks are accurate. Okay, presuming that we're not talking like 2.0000125 or something weird like that. And now that I have all of that, all I need is to remember the equation, x minus h squared. Now this one's tall, so the x direction is the short direction, so it's over b squared, plus y minus k all squared over a squared, because it's tall, because the a is in the y direction, equals 1, and then I just need to fill in. So x minus h, so x minus -3 is like x plus 3, so x plus 3 all squared, over b squared, 1 squared, which is 1, 1 squared is 1, plus y minus k minus -1 is plus 1, all squared, over a squared, which is 3 squared, which is 9, equals 1. And there's the equation for the graph. And there we have it. Questions? I'll pause, give you a chance to look at that, give you a chance to ask questions. Okay, there being no questions, I'll move on. All right, so let's find the foci for this ellipse. And remember the foci, first of all, I can tell this one is wide instead of tall, so it looks kind of like that, something like that. And remember, there is the focus, and then there's the vertex over here, and that distance is A, and this distance is C. And when we have the co-vertex, the minor vertex, and we create a right triangle, this distance is B, a right triangle, the hypotenuse also has a distance of A. That's a property of ellipses. So as long as I have A and B, I can get C. As long as I have the center, I can calculate the distance away, and I just need to know which direction I'm moving in. So I know that B squared plus C squared equals A squared because of the picture. And I know B. B is the square root of the smaller number, so that's 7. Actually, I know B squared, which is even better. So 49 plus C squared equals A squared, which is 625. I can subtract 49 on both sides and get that C squared equals, let me do some side work here. 625 minus 49. I'll have to borrow. That'll be 6. I'll have to borrow again. That'll be 7,576. So let me check that square root on a calculator. And I'm going to do that by turning my calculator sideways. and that'll give me a square root button because it'll become a scientific calculator. And it turns out that the square root of 576 is 24. So I have that. So I have my C distance. So now if I just go from my center, okay, so now my center is at, so it's plus 5 here, so it's the opposite of that. So -5. And it's -7, so it's the opposite of that, it's 7. And then for each focus point, and let me label them different this time. This is 1, this is 2 this time. I just move that distance in that direction and either add it to or take it away from that part of the center. So for example, for F1 here over on the left, I would be moving from the center in the negative x direction. So number 1, I'm not changing the y. And I want to move from -5 in the negative direction by 24 because of that 24 right there. So if I move back another 24, that'll be -29, right? On the other hand, if I want to go to the focus point in the positive direction, that one right there, then I need to move this 24 in the positive direction. So I'll do -5 plus 24, which sounds like 19 to me. And of course the y value stays 7. So there are the foci right there. I'll pause for a moment, let you look at this, see if there are questions. And if not, we will move on. Let me let you look at it just for another moment. All right, there being no questions, let's talk about an ellipse that has a vertex at 14, -1. Okay, so let's start drawing this out. We have an ellipse with a vertex at 14, -1. That mark should actually be a whole lot closer, doesn't it? Okay, so there's a vertex. The focus nearest that vertex is at 8, -1, so somewhere around here. So let's call this vertex 1, let's call this focus point 1. And the center is at -1, -1, so the center is there. So give the equation of the directrix on that side. So there's the directrix line, always beyond the vertex, right? And as a reminder, the directrix distance from the center is a squared over c. So I need that distance right there. Okay? I know the distance A. That's the distance from the center to a vertex. A is 15. From -1 all the way out to 14 is a distance of 15. I know the distance C from the center to a focus point. And I know that distance is from -1 to 8, so that is a distance of 9, right? And so I can get D, I can do 15 squared, which I'm going to double check it, but I'm pretty sure it's 225. Yep. 15 squared, or 225, over 9. So let me divide that by 9, gives me a distance of 25. So D equals 25. And then the equation for that is at x equals, because it's a vertical line, because this thing looks something like that. This ellipse looks something like that. It's wider than it is tall. The major vertex is in the x direction, however you want to think of it. So the directrix will be up and down, that is vertical, and those equations are x equals equations. And so the distance is a distance of 25, but what x value it would be at is actually 24, because for a distance of 25 you have to travel 24 to the 0 and then 1 more to -1. So it's at x equals, x equals 24 is the equation of the directrix on that side. The directrix on the other side is x equals -26, right? -1 plus -24, or plus -25, -1 plus 25. Yeah. All right. I'll let you look at that, see if there are questions. Moving along pretty well here. There being no questions, I'll move on. All right, let's talk about another ellipse. This one has a center at 3, 2, one focus point at 6, 2. So let's start drawing it here. Center at 3, 2, a focus point at 6, 2. So our C distance is 3, right? So this is our center. Let's call this focus point 1. Somewhere out here is the vertex, and somewhere out here is the directrix, and it looks something like that. We don't really know, but what we do know is that the directrix line is at an x value of 11 1/3. So, and we want to write the equation of the line, right? So actually, we already have a lot of it, right? We know it's wide instead of tall, so it's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. And I know that because I drew it and I'm looking at it, and the focus point and the major vertex all runs along the major axis, so it's really easy for me to tell that when I draw it, right? I know my distance C. I don't know my distance A, or I don't know my A squared yet, or my distance A yet, but I'm going to be able to calculate it because I can figure out my distance D from the center to the directrix, and that distance is, so For the center, we're at 3, 2. So the center's value is 3. So I need to do the center's x value is 3. So what I need to do is figure out 11 1/3 minus 3. Let me turn that into all fractions. So that'll be 34 over 3 minus 3 over 1, or 9 over 3. So I have common denominators. 9 divided by 3 is 3. And then 34 minus 9 is 25 over 3. And since that's reduced, I can call that my a squared over c. I could have also set it up as an equation and said, well, my c is 3, and and the reason I don't have to do that isn't because it's reduced. I'm sorry. It's because I already know that c is 3, right? So that sets up nicely for me. But I could have said 25 over 3 equals d, and that equals a squared over c. But I know c is 3, so multiply by 3 on both sides. And the 3's actually cancel, giving me that 25 equals a squared. I can do that algebra, and you may need to do that algebra. Okay? So I know a squared. And then, remember, I know this other little fact, that if I have a focus point and a distance C, C, B, and A works like that. So I know that C squared plus B squared equals A squared. And I know C is 3, so that's C squared is 3 squared is 9, plus B squared equals A squared, which is 25. I subtract 9 on both sides, and I get that B squared, which is the thing that I actually need, is 16. And then I have everything I need to fill everything in. Remember, H and K are right there. So then I can fill in the equation. That'll be x minus h, which is 3, all of that squared, over a squared, which is 25, plus y minus k, which is 2, all squared, over b squared, which is 16, and the whole thing equals 1. And there we have it. I'll pause here for a moment to allow for questions. There being no questions, we'll move on. All right, find the foci for the graph. So we're given a lot of information here. Notice that this graph is taller than it is wide. So the foci are going to be you're going to have to travel in the y direction to get to the foci. There's one here somewhere, and there's one here somewhere. And so if we just find C, we will know that here is our distance B. This would be our distance C. And this is our distance A, but also that is our distance A, right? And so I can count or calculate what A is. A goes from the center out to a vertex. So it travels from -2 up to 4, which is a distance of 6. B is from the center to a co-vertex or a minor vertex. So it travels from 3 to -1, which is a distance of 4. And then the Pythagorean theorem holds true, so b squared plus c squared equals a squared. Maybe I should write my center also. My center, as you can you should be able to clearly see, the x value is 3, the y value is -2. And so I'll manipulate that along the y to do my foci once I have the distance c. So b squared is 4 squared is 16 plus c squared, I don't know c, so I'll leave that, equals a squared, which is 6 squared, which is 36. I'll subtract 16 on both sides. That'll give me c squared as 20. So c is the square root of 20, which is, you can pull out your calculator and get an approximate for that. I'll show you the answer both ways, actually, because it's good to know the answer when you're using that and when you're not. So square root of 20 is approximately 4.47. So approximately 4.47. And this is in the y direction, right? We can tell that by the picture. So let's label these focus points. Let's call this focus point 1. Let's call this one focus point 2. And then I can do things pretty clearly. Okay? So focus point 1. The x value is not going to change. But the y value, I'm going to go from the center to F1, I'm going up. That is, I'm going in the positive y direction. So I'm going to go from -2 in the positive direction by a value of square root of 20. And that gets me there. Okay? So this is the really super accurate way of doing it. And for focus point 2, my x value is still 3 because I'm only moving in the y direction. And I'm going to go from -2, and I'm going to move in the negative y direction by square root of 20. Now, you can do that, or you can pull out a calculator, and you can say, okay, what's -2 plus 4.47? And you get an answer for that. And you could say, what's -2 minus 4.47? And get an answer for that. These are both acceptable. It'll just depend on what Edgenuity is looking for. I'll pause here, allow for questions. We got one question left, one problem left. All right, let's move on to the final question. All right, given this equation of an ellipse, find the equations of the directrices. And I'm reminding you of the d distance right there. Edgenuity is not going to do that. You're going to have that written down somewhere. Okay, so some things to know. Because the bigger number is below the y. This is tall instead of wide. Because there's no set of parentheses there, the x coordinate for the center is just 0. So let's write down some things that we know. The center is at h, which is the part attached to the x, which is 0, and minus k, so the opposite of -2 is +2. So there's our center at 0, 2. We need a, actually we need a squared, right? And a squared is just that number there, 64. We need b squared, which we also have. So let's draw the picture here. We know it's taller than it is wide. We actually know, so it's at 0, 2, which is right there. That's the center. And we actually know, let me make that a little bit nicer here. We actually know the distance out to there is a square root of 64, which is 8. So the vertex up here, well, let me put the vertex here, and then we'll call this the directrix line. So the vertex, call that vertex 1. This is the center. The vertex is 8 away, so that's actually at 10, right? And then if we talk about this as focus point 1, and then would be 3 out or so. So it looks kind of like this. I'm just sketching it out to get a look at it. But I know that all of this is, here's C, here's B, and that makes that A. Okay. So I'm continuing to use that really useful fact for a ton of stuff here, right? Note that these are going to be y equals lines now because we're tall instead of wide. So if you're tall and moving in the y direction, your directrices are going to be y equals because they're going to be horizontal. That is, they only move in the x direction. The y stays static. So you only need to give me the y value for it. But if you want to think of it as it's tall, therefore it's in the y direction, therefore the directrices are y equals, that's probably a decent way of thinking of it. So we need the distance d from here to here, that distance d. So that's going to be something that we have to calculate, right? We have to use this to do it. So we have to get C first. So I know that B squared plus C squared equals A squared from my picture. And B squared is 9. I don't know C squared. A squared is 64. I'll subtract 9 on both sides. And C squared will be 55. So C will be the square root of 55, or approximately, and let me pull out my calculator one more time for this calculation. Square root of 55 is approximately 7.42. So 7.42 4, 2. All right. So then D is A squared, which is 64, over 7.42. It's actually approximately that, which means that D is approximately, one more time on the calculator, 64 divided by 7.42 is about 8.63. So there's that. So that distance is about 8.63, and we're going to move in the y direction from the center that distance. So if I start at 0, 2, and I move in the positive y direction, it's going to be 2 plus 8.63, which is 10.63. And that's going to be the point. That's not going to be the line, but that's going to be the point. And then 2 minus 8.63 is if I move in the negative direction down to that that line right there. So these give me the y's. So one of the equations will be y equals 10.63, and another one of the equations will be y 2 minus 8.63 is negative 6.63. And so these are my answers right here. I'll pause, let you look at that, see if there are questions. All right, thank you so much.